This podcast covers atomic structure and also isotopes. So today, what we consider modern atomic theory says that this is what an atom looks like. An atom is mostly empty space, and it has a small positive nucleus, and the nucleus has protons, which are P plus, and neutrons, which are N neutral. And that electrons are on the outside of the atom, the outside of the nucleus. And electrons are incredibly tiny, and they have a minus charge. This chart here is a summary, and you do not have to memorize any masses, any exact masses, but what you should keep in mind is the relative charges and masses. So protons have a positive charge, neutrons are 0, electrons have a -1 charge, and the relative masses, or atomic mass units, protons have a mass of 1, very close to 1. Neutrons also have a mass of 1, so they are really close to each other, and they're very heavy. Electrons, on the other hand, have an incredibly small mass, 0.0005 atomic mass units. This number is so small that we usually count it as 0. So the atomic number is the number of protons in an atom. It never changes without changing what the element is, and it defines the atom. So when you want to know what element you're talking about, you look at the number of protons, and that tells you. The symbol for atomic number is Z. The mass number, which has a symbol A, is the total number of protons plus the number of neutrons in an atom. It's everything that's in the nucleus. It's everything that's heavy, which is what causes the mass, the heavy stuff. All the particles in the nucleus, that gives you the mass number. The mass number can change because the number of neutrons can change. The number of protons, or the atomic number, that's never going to change. So here's a little bit about symbols. Each element on the periodic table has one name and a 1 or 2 letter symbol. Most element names and symbols are based on English, Latin, or Greek. And note that the capital letter, it always starts with a capital letter, and if it has a second letter, it must be lowercase. So how you write the letters actually do matter. It's pretty precise. Here's some examples of where element names and symbols come from. Carbon, C, comes from the Latin, meaning coal. Oxygen, which is O, comes from the Greek, meaning acid, because a lot of acids have oxygen in them. And then sodium, which you might wonder, why is it Na? That doesn't start with S. That can be a little bit confusing. It comes from the Latin. So these symbols, element names and symbols that don't seem like what you'd expect, they usually are from the Latin words. So natrium is Latin, and that's where sodium comes in from. Iron is Fe, and that's ferrum, and that also comes from the Latin. And you don't have to remember where they come from, but just keep that in mind. Here's how we write an atomic symbol. Oh, a little bit of information. Again, positive, uppercase and lowercase do matter. C and O, lowercase o, is cobalt. But if you have capital C, capital O, then that would be carbon plus oxygen. So you got to pay close attention. How to write an atomic symbol. This is the 1 or 2 letter symbol. There is no element X, so we always use X as like a stand-in. A is the number up on top here, and that's the mass number, which is the protons plus neutrons. Z is the bottom number, which is the number of just protons. And sometimes we can leave off Z, because if you know the symbol, then you automatically know the number of protons. So sometimes this is left off. So for practice, you complete the table. Use the periodic table. You have one. It has the names on it. make sure that you pay attention to the symbols, write the names. The atomic number is the big number on the periodic table, and then it gives you the number of protons. The mass number is the protons and neutrons added together, and you can use that plus the atomic number to figure out what the neutrons are. So try filling in the chart, shut off your tape, and then turn it back on to check your answers and see how you did. So just this first row shows you how to write stuff. So how do we know that it's zinc? Because the atomic number is 30, and you look at that on the periodic table and you say, okay, atomic number 30, it's got 30 protons and it is going to be zinc. Because the mass number is 66, subtract out 30 protons and you have 36 neutrons left. The symbol is written Zn for zinc, atomic number on the bottom, that's 30, mass number on the top, that's 66. So this actually gives you all the information that you need. So fill in the rest of your chart and then check your answers. If you have any questions, make sure that you ask your instructor. So isotopes. Isotopes are atoms of the same element that have the same number of protons, but they have different numbers of neutrons. So they are the same element, but they have different masses because they have different numbers of neutrons. So here are example of carbon isotopes. Carbon has 3 natural isotopes. The first one is carbon 12. The 12 here means it has a mass number of 12. Because it's carbon, it has 6 protons. Because it is neutral, it has 6 electrons. And because the total is 12, we know that it has to have 6 neutrons. Sorry, 6 electrons and 6 neutrons. And then we write the symbol this way. Again, carbon, atomic number 6, mass number 12. You can also have carbon that instead of having 6, it has 7 neutrons here. It still has 6 electrons. It still has 6 protons. But this is carbon 13, mass number of 13. And then the symbol is 13 on the top, again 6 on the bottom. Carbon 14 has 8 neutrons and a mass number of 14. So for practice, you fill in the chart for silicon. Silicon has 3 naturally occurring isotopes, silicon-28, silicon-29, and silicon-30. Use the periodic table to figure out how many protons are in silicon and fill in the rest of your chart. Stop your recording, you try it, and then turn it back on to see how you did. Okay, note that silicon is always going to have 14 protons because that's what makes it silicon. It's always going to have 14 electrons if it has no charge, which these don't. And then the number of neutrons is going to change based on the mass number. So what happens with elements is they come in different isotopes, and you can calculate what's called the atomic mass by taking a weighted average of the natural isotopes of an element. So I'll show you how to do that. So what a weighted average is an average that takes into account the various masses of different isotopes. So for example, 92% of natural silicon is silicon-28, and 4.67% of natural silicon is silicon-29,